All right. So this is from 0 to 0.04, and this one is from 0 to 0.08, or from 0.04. I'll put that in parentheses. Okay, and then for part, so that's the answer to part C. No, part B. No, that's part C. So this is C over here. And then part D asks if one end of the rubber band is attached to a stationary vertical rod and the rubber band is stretched horizontally, what is it? 0.08 meters from its unstretched length. So you have a rod here and it's stretched out this way. That is a terrible 8. Let me try that again. 0.8 meters. No, 0.08. So 0.08 meters from its resting distance. And then you attach a 0.3 kilogram. Is that right? 0.3? Yeah, 0.3 kilogram weight to the end, or an object that weighs that weight. And it's on a horizontal, so perfectly flat. We don't have to worry about weird normal vector things. And it's frictionless, and then it's released from there. And then what is the speed of the object when it's traveled 0.04 meters? So at the halfway point, that's what we're looking at. So to solve for this, the way that we do this is we have to balance out the energy in the system. So the energy from the spring, which the rubber band is essentially a spring, is going to equal the kinetic energy plus the energy in the spring. And I'm just going to put a 1 there because it's the other one. Or we can put a naught over here, the little 0 on this one, to say it's the initial, because it's starting over here at the fully stretched at 0.08. So the equations for that are 1/2 k times x naught squared, because this is our initial one, is going to equal 1/2 times your mass times your velocity squared plus 1/2 k times x squared. So that's our equation. Then we can go ahead and go through this and plug in what we know. So we already have k up here, again, right there. And so we have that. X naught is going to be equal to 0.08. And while we're there, x is going to equal 0.04. So we have that. The mass is equal to 0.3 kilograms. These are both in meters. Let me not forget those. So we have that. We have mass. Velocity, this is what we're trying to solve for here. We have k already, and then x as well. So at this point, all we need to do is go ahead and plug those into your calculator, and you should get the answer. So let me do that real quick. So it's going to be 1/2 of all of that. So the nice thing here, one more thing I'll say before I plug everything in, is each one of these terms has a 1/2 out in front of it. So there, and there. So you can actually take this entire equation and multiply it by 2 and just get rid of all the 1/2 so you don't have to deal with them, which makes plugging things into your calculator a lot easier. Also, before I plug this into my calculator, I should probably explain what it is I'm doing. That was mass, right? That I erased that I wasn't supposed to? Yes, because it's 1/2 mass times velocity squared. Okay, so what I'm going to do on this is I'm going to take this part here and subtract it from both sides. So it'll be this minus this, and then I'll divide by m and then take the square root. Yeah, just algebra things. So the end result should be the square root of k, which is so k will actually also change with the distance because it's in terms of x. So for the first k you'll use x naught, and the second you'll use x. So it'll be 0.4871 times 33.55 times x naught, which is 0.08 to the 1 point. Oh wait, no, that's not right. Delete that. To the negative 0.5129, or yeah, 29. 5129. Is that right? Yes. Yes, that is right. Okay. So you'll take that minus your second k, which is 0.4871 times 33.55 times 0.04 raised to the negative 0.5129, and then all of that's going to be divided by our mass, which is 0.3, and then we'll take the square root of that, and that comes out as a non-real number because I put something in wrong. Woohoo. Okay. Let me break this up a little. So 0.4871 times 33.55 is going to equal the number in front of the x in k. So we'll break this up one at a time. Oh, x naught needs to be squared. That's what I did wrong. Okay. Let me just write this down so I can make sure that I don't screw things up. So it'd be k naught x naught squared minus k x squared all over all over m, sorry, and then the square root of all of that. Alright, so that's the square root of parentheses k naught, which is that times 0.08 to the negative 0.159 times x naught squared, so 0.08 squared, minus our number there, times 0.04 raised to the, what's that, negative 0.5129 times 0.04 squared divided by 0.3, and that should equal our number. So that comes out to be 0.905 meters per second. Bada boom, bada boom. And that should be it for that problem. And it is. Alright. So that's problem 90.